Every atom in your body should not exist. The chair you're sitting in, the planet beneath you, every galaxy in every direction, all of it should be empty radiation cooling toward absolute zero. The math is clear. When the universe was born, matter and antimatter were created in perfect equal amounts. They should have annihilated completely. Nothing should remain. No stars, no planets, no you. And yet here you are. So what broke? What impossibly rare accident let anything survive at all? Here's what we were taught. Energy converts to matter, always in pairs. One particle of matter, one particle of antimatter. They're identical except for charge. When they meet, they destroy each other. Complete conversion back to energy. Think of it like shuffling a deck of cards with perfect symmetry. Every red card paired with a black card. You should end up with nothing unpaired. In the first fraction of a second after the Big Bang, the universe created unimaginable amounts of matter and antimatter. Temperatures hotter than any star. Densities beyond comprehension. And these particles found each other almost immediately. The annihilation was nearly total. Nearly. Because something didn't balance. Physicists call it baryon asymmetry. For every billion antimatter particles created, there were 1,000,000,001 matter particles. That one extra particle in a billion is everything we see today. Every human who ever lived, every star that ever burned, all from a rounding error in reality. But here's where it gets strange. We don't know why that asymmetry existed at all. The laws of physics, as we understand them, say this shouldn't happen. There's a principle called CP symmetry. It says matter and antimatter should behave identically, create them equally, destroy them equally, no leftovers. Imagine a perfectly balanced scale. You add weight to both sides at exactly the same rate. The scale should never tip, but the universe's scale tipped. We've found tiny violations of CP symmetry in particle accelerators. Certain particles decay slightly differently than their antimatter twins. Wait, this is where it breaks your intuition. These known violations are too small, by a factor of billions. The asymmetry we observe in laboratories can't explain why we exist. It's like finding a single drop of water and trying to explain the Pacific Ocean. The standard model of physics predicts some imbalance, not nearly enough imbalance. Something beyond our current understanding created the surplus that became reality. Some unknown particle, some unknown force, some interaction we haven't discovered yet. Which leads to the part that most people never hear about. This isn't just a puzzle about the past. It's a statement about possibility itself. Consider what this means. The universe exists because of a violation of symmetry so subtle we still can't reproduce it. One extra particle per billion. If that asymmetry had been slightly smaller, there wouldn't be enough matter for stars. No stars means no heavy elements. No heavy elements means no planets, no chemistry, no life. If it had been larger, the universe might have evolved differently. More matter means stronger gravity. Perhaps everything collapses too fast. The asymmetry was precise. Not too much, not too little. Exactly enough to build a universe capable of looking back at its own origin. 14 billion years of cosmic evolution rests on an imbalance we can detect but not explain. Some physicists believe this points to new particles, heavy particles that existed only in the extreme conditions after the Big Bang. Others think it reveals something fundamental about time itself. That time has a direction because symmetry was broken. Cause and effect exist because the universe chose matter over antimatter. So the real question is, does this change what we think is possible? Right now, teams at CERN are smashing particles together to find CP violations we haven't seen before. The Large Hadron Collider is running experiments specifically designed to catch matter and antimatter behaving differently. Researchers in Japan are studying neutrinos, ghost particles that pass through planets like they're not there. Neutrinos might violate CP symmetry strongly enough to explain our existence. The T2K experiment fires neutrino beams across 295 kilometers. They're measuring whether neutrinos and antineutrinos oscillate differently. Every month brings new data. Scientists are building the next generation of detectors. Larger, more sensitive, capable of catching the rarest interactions. This isn't theoretical curiosity. This is the question. Why is there something rather than nothing? And somewhere in a laboratory, possibly within the next decade, someone might catch the particle that answers it. Look back at that first moment again. Perfect annihilation should have erased everything. But it didn't. 1 in a billion survived. And those survivors became the 100 billion galaxies we can see. They became the 100 billion stars in our galaxy alone. They became you, wondering how any of this is possible. We're here because the universe broke its own rules in a way we still don't understand. So I want to know, do you think we'll find the particle responsible within your lifetime? Or is this a mystery that outlives all of us? Follow for more. We post every week.